Hello guys, what we're going to do today is we're going to talk about chapter 8. I'm going to try to get most of it done in this if possible. If not, I'll make it into two. We're going to do what's called hypothesis testing. I'm actually going to walk you through your packets. So I'm going to give you something like this. It says chapter 8 with a bunch of my handwriting that kind of follows us through some stuff. And then packets A22, which is a big packet, it'll have A23 embedded in it, and then A24. So those are the things that you're going to want to grab if you want to pause this and grab them first. So let me talk about chapter 8 in general. It's called hypothesis testing. What happens is when we go out in everyday life, we hear on the radio, which we already discussed this, on the radio, on the internet, in newspapers and magazines, on the television, people give us statistics all the time. So it's our job to see, hey, are these statistics true or not? A lot of times they just tell us this and we assume they're true. But then if you see them, on the internet or something and you kind of question it, there's ways to either prove or disprove some type of statistics. So that's what we're going to talk about. So what hypothesis testing is somebody's going to give you a statistic and then you're going to disagree with it somehow, or you're going to want to affirm it. So for instance, let me just say the average ACT score in the United States for all high school juniors was 21. Some of you are going to be like, man, I bet it's higher than that. So what happens is we do a hypothesis test to see, okay, is it higher than the 21 that the original study said? So let's just kind of roll through with that. So I'm going to say that the average ACT score of high school juniors ended up being 21. So this is what happens. People are going to, number one, going to want to know, does it differ than that? Like, is it different? They don't care if it's lower or higher. They just want to know if it's different. They want to know, is it greater than 21? Is it less than 21? And then some people may want to say, you know what, I think it's right on 21. So no matter what you want to do, those are the only four possibilities, is we want to do a hypothesis test. So this is what's going to happen. If somebody says something is, they want to claim it's greater than, we use what's called a right tail test. So I'm going to assume that it's greater than. So if you see the word greater than, it's going to be right tail. And I'll kind of go over that with you. If I say that it's less than, it's going to be a left tail. If I want to say that it differs, means it's different, or if I want to affirm it's 21, I want to use a two-tail test. Here's the only troubling part that I think a lot of students struggle with. Sometimes they're going to want to affirm that something is. So if somebody says, yeah, I think it's 21 also, what we're going to do is we're going to assume the original study is always correct. So we're going to assume it's 21. But then what we do is we try to disprove that it's not 21. And this is going to sound weird, but if I try to disprove it's not 21 and I can't disprove it, I'm really affirming that it is 21. So that's kind of like the hardest part. So if I say, hey, I think that it's greater than 21, and I try to prove it, and I can prove it's greater than 21, then I say, yeah, it's greater than 21. If I can't, I say, hey, I don't have enough information to prove it's greater than 21. If I want to say it's less than 21, I can do my statistical study, and I either am going to have enough evidence or I'm not. If I have enough evidence, I can say, you know what, I can prove that it's less than 21, or I can say I don't have enough evidence to prove that it must be 21. If I say that it differs from 21, I assume it's 21, and I'm going to try to, prove that it's not. Okay? Well, the tricky part of that is if you ever just want to affirm something, you're going to assume it's true, and you're going to try to disprove it. But if you can't disprove it, you're technically assuming that it's true. So that's kind of like the hard part. Most of them are greater than or less than, though. So in hypothesis testing, we are going to see something. It's called the original study. We're always going to assume that's true. Then we're going to gather information and we're going to try to prove our claim. And our claim is either that it's going to be less than, greater than, differs, or we just want to affirm it. If it's greater than, it's a right tail. Less than, it's a left tail. If it's either of the other two, we're just going to call it a two-tail test. Now, the verbiage gets a little, difficult here, I think. But we have what's called a claim, and that's what I'm going to claim. I think it's greater than, it's less than. The counterclaim is always going to be the original study. Well, when we talk about hypothesis, we have to get into technical terms. The counterclaim, which is the original study, is also called the null hypothesis, and we just label it H sub 0. For me, other statistical teachers want to say, the opposite. For me, we're always going to assume the original study is correct. So my H sub 0 is that my ACT score is equal to 21. I'm going to assume it because that's what my study said. H sub 1 is going to be my alternative hypothesis. That's my claim. So somebody's going to say, hey, I think it's greater than 21. So I'm going to say my ACT score is greater than 21, or less than, or it just differs. And then you'll see these little boxes when I get to the template so you can kind of see what I'm talking about. So that's the overall idea of what we're going to do. We're going to have an original study, and that original study is going to be my null hypothesis and my counterclaim, and we're going to assume my original study is always right. Then I'm going to get information, sample sizes, and we're going to try to prove that they're wrong. So I'm going to kind of get a sheet out and show you how we do that. Okay, so the first thing that you're going to see is this, although yours won't be pretty yellow like mine is. Hypothesis testing, I just put on there just all the sums up. If it's greater than, it's the right tail. If it's less than, it's left tail, so on and so forth. For sample size, we're going to do like we've always done. If it's 30 or more, it's Z values. If it's 29 or less, it's T values. Guys, instead of looking up table E or F, if you go to the packet that says A22, in the middle, there's a mini table E. I think it says mini table, and you can actually just look on that instead of looking it up in the book. So that'll help you out and it'll shorten up the time. I put on here what all these things mean and what you're going to look for. Okay, so let's just get straight to a problem. So in 22, this is what's going to happen. And sorry, I have it like this. They're going to say, according to the U.S. Department of Education, full-time PhD students receive an average salary of $12,000. The dean thinks that his earn more. Okay, so that's going to be the key. He surveys 44 and finds the average salary is $13,000 with a standard deviation of 15. When they say with a tail of 0.5, that's really like a 95% confidence. They're saying the tail is 0.05. Now, since it's more than, it's going to end up being a right tail. So if we look, this is what the right tail was. So a tail of 5 means that this is the 5%, that's the 95. So when we go to look it up, you can actually just look up a tail of 0.05 in the mini table. It's really easy to use, and that'll give us our critical value. So the main thing is I want you to understand what this problem is asking. A study found out that PhD kids earn $12,000. This guy thinks that it's different. So you just can't say it's different. So he goes out to prove it's different. So he surveys 44 people and found out their salary is 13 with 1,500. So the idea is with a tail of 0.05, meaning with 95% accuracy, is the dean correct? So this is how you're going to set this up. You're going to say the population mean. You need to put this out in words. What do my numbers mean? Well, the $12,000 is the average salary of a full-time PhD student. Then the hypothesis claim, I always want to see the words differs, doesn't differ, less than or more than. Here it's going to say the state PhD students earn more. Then what happens is you have your claim and your counterclaim. This counterclaim is the original study. You're going to say that mu equals 12,837. So whatever your original study is, mu equals that. We assume the original study is correct. Our claim, he thinks that it earns more, so we're going to say mu is greater than 12,000, whatever. So then to get to our finding critical values, H sub 1, this is called my null hypothesis. This is always my counterclaim, so these two things should always be the same. H1 is my alternative hypothesis. Well, that's my claim, so these two will always be the same. Now this test, you need to tell me two things. Are we using Z values or T values? Well, my sample is 44 people. That's bigger than 30, so I'm going to use Z values. It's a more than, so it's called a right tail test. So N equals 44 is my sample size. My tail is 0.05, which is really like a 95%. So what we do is we look up 0.95 in your table, in your book if you want, or the mini table, which is going to be the quickest, and you get 0.165. So what you do is you go to this and you put 1.65 right here. And so 1.65, so let me shade that in so you can see it just a little bit better here. This is my critical value, all right? Now what happens is I'm breaking this up, and what this is really going to tell me is I'm going to get a test value. If my test value is over here, I do not reject my null hypothesis, which means I don't have enough evidence to say my claim is right. I need to make sure I prove something. In order to prove it, my test value must be greater than my critical value. Now, if it's a less than, then it must be less than it, like if it's over here. But if it's on the positive side, over here's my critical. This means that I can reject my null hypothesis, and that means my alternative hypothesis is true. So how do I find my test value now? Well, to find the test value, you're going to use this formula right here. You have your sample mean, your hypothesized mean. Your hypothesized mean is your original study. Your sample mean, if you go back up to the problem, was 13,000 standard deviation sample size. You plug it in, this formula, make sure you put this in parentheses whenever you put in your calculator, and your test value ends up being 2.68. So I'm over here. That means that based on the location of the test value, make the appropriate decision. So you're going to reject H0. So if you're to the other side of it, you can reject that. So based on the sample, there is enough evidence to claim that the State University full-time PhD students earn more than $12,837. Okay, so the original study was that it was 12,000. He did a little thing on his own, a little statistical study to find out, hey, can I prove that it's greater than this? We find a critical value by using my tail and sample size, and that tells you that we got 1.65. And then when you do your test value, since it was over here, this tells me I have enough information to show that I can prove that my kids earn more. Okay, we're going to do another one, but we're actually going to move to the 23 packet on this. So if you just flip to the first example of this, and I apologize that it's going to be a little short-handed on here. Let's actually go to the second example. That may make it a little bit easier. Okay, so in this case, they're going to say the National Teacher Association state that the average salary teacher substitute gets $60 a day. So an educator took a random sample of 8 districts in his state and found the average salary to 58 with a standard deviation of 5. Can the educator conclude that the average salary is less than the national average? So here's one that's going to be a less than. So mu, I did not put it on here, but we go to whatever this dollar amount is. And so what does that number stand for? Well, the $60 is salary sub pay. So it's the average daily salary that a sub gets. Hypothesis claim. If you look, we saw the words that it's less than the national average. So the hypothesis claim here would be less than the national average. So my counterclaim, this is the part that I wanted to make sure we did. The counterclaim is that we always assume the original study is right. So mu is going to equal $60 per day. My claim is that it's less than it, so I want to prove that it's less than 60. So then we come down here. H sub 0 is going to be your counterclaim. So this H sub 0 should read mu is equal to 60. H1 is your alternative hypothesis, so this is going to be mu is less than 60. For the test, it's a t-value because my sample size is less than 30. And it's going to be a left tail test because it's a less than. So then we come here and we say it's 8. My tail is 0.10, which means it's 90%. And so if we look it up in mini table E, it'll tell you that if it's a left tail and its sample size is less than 30, you get 0.14 or negative 1.415. You could actually look this up in table F if you wanted. And so I just want to show you how to do that too, just in case you can't get the mini tab. So if we go to table F, the degrees of freedom, remember, is 1 less than my sample size, so it's 8 minus 1. Now if we look, this is a left tail and right tail are called a one-tail test. So 0.1a or 0.10 up here at one tail, that's where I want to be. It's one tail because it's a left tail only. It's 0.10, and I come down here. And so that gives me 1.415. Now, because it's a left tail, I have to add the negative on there. So that gives me what my critical value is. Well, my critical value is right here. So if I want to prove that something is different, if my test value falls on this side, I don't have enough information to prove. But if I ever fall on this side, that means I have enough information to prove that it is less than 60. So if you do your test value just like we did in the last problem, all right, you're going to end up with negative 0.62. So we can see here that I fall in a range that does not give me enough information. So what we have to conclude is I do not reject the null hypothesis. I don't have enough information to prove that it's different. So based on the sample, there's not enough evidence to claim that the substitute pay is less than $60. Okay, so that's two quick examples there. Now, the last thing I want to do is talk to you about if we have comparing two means. And in this case, this is what your front packet's going to look like. It looks all crazy, but don't let this scare you. It's going to be the same exact thing. Instead of comparing to numbers, though, we're going to compare two separate sets of data. So I'll have my null hypothesis, my alternative hypothesis. It's either going to be a two-tailed test, a right-tailed, or a left-tailed. So this kind of walks you through everything step by step. Here's the only tricky part is this is how I'm going to do my test value now. Okay, so let me just show you a quick example of how to do this, and then we'll see what's happening. All right, so here's problem one. It says a study was conducted to see if there was a difference between a hotel room in New Orleans and Phoenix. Just for instance, just to let you know, if you get a hotel room in Lincoln compared to Chicago, Lincoln's going to be way cheaper. You know, the cost of living is cheaper. So this is one thing we can compare. So what they'll do is they'll give you a list of the two data. Don't worry about the ends. They don't have to be equal, you know, and they're always going to be bigger than 30. Okay, the only time you use them is going to be in this formula down here. So that's the mean, that's the standard deviation. So what's let mu1 equal? Well, unfortunately, even though I put 8842 here, that should actually read that mu1 equals the hotel rates in New Orleans. Mu2 is the hotel rates in Phoenix. Now in this sign, if you read it, we want to say that there's no significant difference. So this is the tricky problem to where I want to prove that they're the same. How do I do that? Well, I'm going to assume they're different, or I'm going to try to prove they're different. So I assume that mu1 equals mu2. So I'm going to assume that they're the same. You know, nobody telling me they're not. So I'm going to assume they're the same. I'm going to try to prove they're different. Now, if I prove they're different, then I have to say they're different. But if I can't prove they're different, I'm really saying there really is no difference between them. Okay? So mu1 equals mu2 is always going to be your hypothesis, null hypothesis. Then H1 is always going to be your alternative hypothesis. So now we come over here and we do the same thing. It's always going to be table Z because we're going to have sample sizes bigger than 50. Here's the only tricky part. If I just say differs or don't differ, my tail is 0.05. But if it's not a greater than or less than, it's a two-tailed test. So what I must do is I must break this up into two. So if you take 0.05 and divide it by 2, you get 0.025 is what you're going to look up in the mini table. If you look that up, you'll see that it's 1.96. And that gives me my two critical values. And since it's two-tail, it's plus or minus. So all you have to do is you come down here and you plug right in this formula. If you do this properly, you get 2.68. Well, 2.68 is to the right, so that means that I can reject my null hypothesis. My null hypothesis is my counterclaim. I'm always assuming that this is a true study, that they're equal, all right? But now I can reject that and say I have enough information to say that they're equal. So in this case, what I want to actually say is, if I go back up here, can it be concluded that there is no difference? Well, I assume there is no difference, and I actually prove there is a difference. Okay, so I just proved that there actually is a difference. So can it be concluded that there is no difference? The answer would technically be no. New Orleans is actually going to be a little bit higher statistically. Okay, I will give you guys a review assignment for this, and I'll post some problems to give you a little more work to do on them, and hopefully we can work through them. Feel free to call me and email me anytime you need to. Thank you.